right? So we'll be solving add two numbers. I feel like this is one of those linked list problems, for generally lead code problems, that when you solve, it kind of like, if you solve it in the morning, it gives you confidence for the rest of your day. But it's also one of those questions that even though you solved it before, I've solved this question. I think I solved this question a while ago, and I still don't feel as confident to attempt it again. Because I'm still going to be reading through it and like trying to figure out, okay, what's my thought process here. Anyway, so the problem says you're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit. Add the two numbers and return the sum as a linked list. Okay. You may assume that the two numbers do not contain any leading zero. Thank you for that, except the number zero itself. And I give us a couple of examples, right? We have 2, 4, 3, and 5, 6, 4. And that means 2 plus 5 is 7, 4 plus 6 is 10, 0 carry 1, 3 plus 4 is 7, plus 1, 8. And the output is 708. Okay, and then we have 0 and 0 here, and then 0. And I think one of the reasons why I like this problem is the fact that, number one, we know that we are going to always have something in the list. It says it's a non-empty list, so we don't have to worry about that edge case, right? One less thing to worry about. And then we have this very long number here, and with L2 here, and this is supposed to be our output. In fact, let's actually use this particular number here to kind of visualize how or what I think this solution should be. So this is 7 nines, so that's basically 1, 2. I have amazing 9 writing style. 3, 4. Okay. 5. That's a lot of nines. 6 and 7, and then we have the other one, just 4. All right. So we have 1, and then we have 2, and then we have 3, and then we have 4. Okay, so basically it's supposed to be elementary mathematics where we just have to sum the two numbers, right? And that should just give us our solution. So we have this here, and technically we should be saying, okay, 9 plus 9 is 18. So it's 18, so we write 8 and carry 1, right? Then 9 plus 9 is 18. 18 plus 1 is 19. That's another 9 and carry 1. 9 plus 9 is 18, plus 1, 19. Write 9, carry 1. 9 plus 9 is 18, plus 1 is 19. 9, carry 1. Now 9 plus 1 is 10. So 0, still carry 1. 9 plus 1 is 10. 0, still carry 1. 9 plus 1 is 10. 0, and still carrying 1. Now we just put our 1 here, and we're done, right? Seems simple enough. So the only problem we have here is to decide how to know what to carry, right? So we have 9 plus 9 is 18, and technically we're supposed to, so we need to know, how do we know what to carry and what to keep? That's it essentially, right? Now if this is divided by 10, 18 divided by 10, right? Or we can actually use modulus here. 18 modules 10, right? If you don't know what modules it does, basically it returns the remainder. Now the remainder of this should give you 8, and that's the 8 we write here. Then 18 divided by 10 should just give us what to carry, but then we have to floor it to be able to get that maths right. So maths.floor, and that should give us what to carry. And that's it. We've actually solved this problem, right? Seems easy enough. You could actually pause this video while I do that around here and maybe try to solve the problem. Thinking about the solution the way I just explained it. You know, the most important thing here is to know that you have to keep going until you don't have the list one and the list two. And when you are done, you need to make sure that you don't have any other thing in your carried value. And how do you get the carried value? Is how you get your carry. It makes sense. I hope it makes sense. And then how do you get the value you write down? You get that by doing the number, this sum of the number modulus 10. So this gives you the value itself. All right. I know that this problem can be solved recursively, but I'm actually not going to be solving this problem recursively. I'm actually going to be solving it with a normal while loop. Plain old while loop. Mostly because I feel very confident with while loops. Not just while loop, like I feel very confident with that. So I'm not very confident with recursion yet. Which means which is the more reason why I should use it, right? But for the sake of this video, we'll actually just go with the while loop. Right, so the first thing we do, we define our variables. Now I just want to have a dummy, and I want to have this node 0. All right, now what's the next thing that we want to have? We want to have the carry, right? Let's call it remainder actually. So the remainder is going to be 0 on a normal day. Yeah, and that means that we always have to check, because if it's 0, then we definitely do not want to add it to the end of the list when we are done, right? If our remainder is 0, it means that, well, we don't have any, there's nothing remaining, so we should just move on with our lives, right? Great. Now what do we want to return? We definitely want to return our dummy dot next. Yep, that's what we return. So now, while we have our L1 or we have L2, we want to keep going. And so essentially what are we going to be doing? When we are at a particular point, we want to check the head of that list. We want to sum the head of that list with the head of the next one. So let's call that, so what do we call that now for the sum of this first one? Let's actually just call that value, right? And we're actually summing up the value, not the L1 itself. So L1 dot value plus L2 dot value, right? Now we need to do this because it's only, well, we need to add that up, and then we now need to decide, okay, does it have a remainder? And if it doesn't have a remainder, okay, what exactly do I need to put on my dummy dot next? I hope that makes sense. Okay, so I have this as my value. So yeah, so now we have the value. Now we just need to decide, okay, what's going to be in our remainder. Our remainder is actually going to be because that whatever you add here, it should always be equal to 10, right? Technically 10 is like the highest you can go, right? Before you can be able to carry, before you should be carrying, right? That's why we are dividing by 10. I don't know if I'm doing justice to that explanation, but okay. So we want to get the value divided by 10, because in a case where we have 5 plus 2, for instance, it's going to give us 7, and 7 divided by 10 is going to be 0.7. Now math.floor of 0.7 is going to be 0, so the remainder is going to be fine. But in the case where we have, let's say I don't know, let's say 9 and then 9, right? Let's say this first value here is 9 and the second here is 9. 9 plus 9 is 18. 18 divided by 10 is going to give us 1.8, and the maths.floor of that is going to mean 1, right? So the remainder is actually 1, which is correct. Good. Now, we need to decide what our current is. I don't know if I should have, but it's of 1 anyway. So let our current be equal to, now for this one here, our value is going to be modules 10. Why? Because let's say we have 2 plus 5. 2 plus 5 is going to be 7. 7 modules 10 is going to be 7. So that's our current value, right? Great. So we just need to do dummy.next is going to be equal to current, right? And dummy. So we are just basically moving our pointers here. We set the dummy.next to be equal to current. Then we set our dummy to be equal to dummy.next. So essentially just moving our pointer. And then we should not forget one more thing, which is, so we first summed these two values, that's 2 and 5. We definitely want to move our pointers from 2 to 4 and from 5 to 6, and we have to do that together so that, at the end we're sure that, we have that sum, right? Great. So that's L1 is now going to be equal to L1.next, and L2 is going to be equal to L2.next. Great. There's one more thing, right, I am trying to think about. So let's say we have one value longer than the other. So let's say we have 1, 2, and let's say we have 1, 2 for the let's say we have 1, 2 for the L1, and let's say we have 3 for L2, right? So it's going to be 1 plus 3 is going to give us, definitely going to give us 4, right? And it's going to give us 4, and then 2. Now 2 plus null is going to give us something like undefined or something like that, and definitely break our code. So that's the reason why I'm thinking about having a check for that, right? This might be redundant, but just to be on the safe side, actually, if I have L1, and have L2, right, that's when I'm going to define my value as this. Otherwise, what do I want my value to be? I actually just want my value to be, let's just keep it at 0. Yeah, but when we have this, I want you to be this. Okay. Otherwise, if we have L1, then I want the value. Oh great, I wasn't even assigning it to anything. I want the value to just be equal to L1. Else, I want the value to be equal to L2. Okay, I think this is just like a measure that I'm taking to make sure that I don't have one when I have one value longer than the other, it's accounted for, right? And if you remember here, actually, I want, when I'm done, I want my dummy.next to still be equal to, let's actually create a new list node that is going to be equal to the remainder. But I only want to do this if remainder is greater than 0. If it's greater than 0, it tells me, oh yeah, I have a remainder, so I should definitely do this. Otherwise, don't. Right, now there's one more thing that's bugging me, which is the fact that what we are having here actually are the values, right? So what we're having here are the values. So we have L1 dot val plus L2 dot val, and that's what we have here. And the values here are what we have here. So remainder equal to matter floor. Okay. This is correct. This is fine. It's when we get to this point. Yeah, definitely. I think that dummy.next at this point could also do it in new list node of current. If you don't understand what I'm doing, because I am setting their values and not the node itself, so which is going to present problems for me. And I actually, you remember working with linked lists, I actually want their nodes. I actually want them to be nodes, otherwise I can't really save them here. Does that make sense? So that's why I'm just creating it as a node and then assigning the next value to that node. And yeah, I think this should solve this problem, but let's just run that test to see. Oh my god. Okay. Okay, let's just check why we have one plus val dot L2 plus L2 dot val. Oh my god. Even though I don't think this should be the reason, but okay. Current is, I feel like it never actually gets in here, which is so weird, because I'm like, okay, while I have L1 or I have L2, then definitely get in here. And then I get in here and I'm like, okay, if you have both of them, sum the value. If you have only L1, put the value here. If you have L2, put that value there. And and I'm like, okay, this is going to be your remainder. And then I'm like, okay, this is going to be the current value here. And I'm like, okay, let the dummy.next value be equal to new list node at the current value, and then dummy here is going to be equal to dummy.next, and L1 I practically just like say, okay, you know what, L1 become the next L1.next and L2 become the next L2.next. I'm not seeing the problem. Okay, dummy.next, new list node. Okay, I am going to actually, let's just confirm that this gets here. So yeah, this is a process, right? You solve it, try, come back. Okay, so it comes here, right? You see I have 2 4 3 5 6 4 and 4 3 and 6 4. So I'm definitely getting in here up until the last point. Oh, I think I know what's wrong. Why? Tell me that next. Oh, I know what the problem is. I know what the problem is. Okay. I know what the problem is. Okay, let's create a new node, which I'm just going to call, what am I going to call it? I'm running out of names. Add. Okay, and then we just call that dummy. That way, if I do add dot here, add dot next, and then I move add to be equal to add dot next. Great. Now when I check this, it should be fine. And this is supposed to be add dot next. Okay. Let's see. Okay. now I have a new problem, which is that it's ignoring my last carry. Why would it do that? Okay, let's check. So we have 3 plus 4, which is 7. But at this point, we had, oh my god, we're not including the carry. Am I for real? Oh my god, we're not including the remainder in our calculation. So of course, so that's all we have to do here. This is like an honest to god way that I solve my problems, right? So that you can actually get to see the process flow. This is what it is like. I run my code, I try, I check my bugs out, and then I try to fix it. I usually try to fix my bugs before I run it though, because it's good practice, right? It's good practice. Oh great. So we're going to run this when we have both, right? But when we just have, let's say we just have L1, then we definitely just want to do L1 to be equal to L1 the next. Sorry about this. And then L2 is going to be equal to L2 the next. Now if this was a recursive function, would have just written a check here for when it stops being like, if it's undefined, don't worry about it, kind of thing. Yeah, I hope this passes all the tests, because with the amount of problems we've run into just trying to submit this, I really hope. Oh, and it does. Yay. And it's not so bad in terms of runtime. So yeah guys, this is how I solve that problem. I use the while loop to check if I have both values. If I have both values, I add the two of them with the remainder, and then I move my 2 pointers. If I just have the one value, I add that value plus the remainder, and I move the pointer, right? And then the same thing with if I have the second value. And then how do I decide what's my remainder? By flooring the division of the value. And then how do I decide what I need to add? By finding the modules of the sum, right, of the values by 10. And then I move my pointer here. And then if at the end I still have a remainder, I add it to my list node and I return the value, the next. I hope this was not so difficult to follow. And if you like my videos, don't forget to like and subscribe. And I'll see you in the next one. Bye.